Welcome to Mathematics for TF learners. In today's lesson, we're going to be looking at the Euclidean Geometry. And if you haven't subscribed on my channel, please subscribe and like, and don't forget to hit the notification button in case there is any video, new video I post. You will find it as soon as possible. And again, and this question actually that we're going to be looking at today is extracted from one of the previous question papers. And students, if you want to find it, please can also go check it on the internet and write previous question papers. Then we will show you and you will check it there. Right. So let us start with our today's lesson. So as I said to you, this is question 9 from one of the previous question papers, and it says in a diagram, P, V, and VQ are tangent to the cycle at P and Q, and the PQ is produced to S, and the chord PR is produced to T, such that VTS is parallel to RQ, and VQ and RT intersect at W, and they said the only P1 and only P2 are equal to X. So student, it's very important that you understand the statement given to you, right? You must be able to interpret it using the diagram given, right? So let me take my laser point here. So as you can see, so firstly they are saying PV and VQ are tangent to the cycle at P and Q. Where's our P and Q? Here's our P and Q. So this is a PV and this is a VQ. So they touch the cycle at the circumference, right? So the definition of the tangent is a line that touches the circle. That is just touches the circle, right, at the circumference, right? So you must understand all those definitions. And they also say PQ is produced to S, right? So PQ is our PQ. PQ is P and Q produced to S. Here's our S. And they also say, and the chord PR is produced to T. So here's our chord PR. So our chord PR here is it P and R is produced to T, right? And such that VTS is VTS is parallel to RQ, right? As you can see, this is how we symbolize the parallel lines using those arrows there, right? And they also say VQ and RT intersect at W. So here's our VQ, is our VQ and RT, they intersect at W this way, right? So it's very important, children, that you take note of this, right? Because they will help you to answer the following question, right? So they also say P1 angle P1 is equal to angle P2, and the angle P1 and P2 are equal to X, right? Here, as I said, this is P1 and here's P2, and both of these angles are equal to X, right? So please take note of this, right? So let's start by number 1. So number 1, they say prove that number 1, which is 9.1, So they say prove that angle S is equal to X. And number 9.2, they say prove that PQ TV is a cyclic quadrilateral. And also number 3, they say TQ is a tangent to the cyclic passing through Q, W, and P. And before you start answering your question, you must always check the marks allocation, right? So the marks allocated for that question or that particular question, you must always check the mark allocation so that you'll be able to answer the question as needed. You might be able to see how many steps are required, right? So it's very important, student, that you take note of that as well. So let's start by number 1, which is 9.1, right? So it's our here's now is our 9.1, where we were asked to prove the angle S that is equal to X, right? So how are we gonna prove that, right? Remember, you were given P1 and P2, right? So you must bear that in mind. You can even highlight it if you have a pencil or if you have a highlighter of any color, then you can just highlight it so it's easier for you to work out what is needed, right? So they say there P1 is equal to X, right? Why P1 and P is given. So we're given that P and P1 is equal to X, right? And they also say P1 here, as you can see there, now is equal to a Q1. Why is equal to Q1? It's because of a tan chord theorem, right? So you remember, if you may recall from grade 11 textbook, we have the theorems there from 1 up to 9. Yes, so all the theorems we must know them by heart, right? It is very important that you know them. So theorem 9 talks about the tan chord theorem. You can say also that the theorem number 9 can also say is the angles between the tangent and the chord. So if you say is the angles between the tangent and the chord, here's our tangent, as you can see, and the chord P and R, right? So you can say it's either you can say is the angle between the tangent PV, right? Here's our PV, right? And the chord PR, right? So you can say it like that, or you can just say is a tan chord theorem. Why? Then there's a reason. There's a marks for this, and there's a marks for the reason, for reasoning, right? So that's how we do it, right? So now we have angle Q1, right? Right. So since we have angle Q1, and now we say now angle Q1 and angle S are equal. So where is our S here? Here is our X, right? But remember that before you consider the corresponding of angles, you must go back to your statement and check there. Remember that they said here in the statement VTS is parallel to RQ. VTS is parallel to RQ. Remember, we were taught in grade 9 about the parallel or corresponding angles, alternating angles, co-interior angles. So we also consider those angles here, even if we are solving solving questions on Euclidean geometry. So it's very important, student, that you also recall of what you've learned in grade 9, grade 10, grade 11, and grade 12, right? So if you don't remember, you can write it down just now, As now the corresponding angles, coincident angles and alternating angles. But these angles, they are only applicable when there is a parallel lines, right? They are only applicable when there is a parallel lines. So here we are told that RQ is parallel to the line R VTS, right? So now we know that we have our Q1 as X. Now we can also say Q1 is equal to angle S, and Q1 is equal to angle SY because they are corresponding angles. In other words, you can also say they are forming a angle shape. So that's why they're saying always when you're told the corresponding angles, they are forming a what? A F shape. So now we are done. So since now we have proven that above that xx is equal to q1, therefore our s is equal to x. So now we have proven that s angle x is equal to x. Then you have your marks, right? So let's move on to the second to the next question. 9.2. So 9.2 says prove that PT QV is slightly equilateral, right? PTQV is a slightly equilateral. So before you solve these kinds of questions, you must understand firstly properties of a slightly equilateral. So it's very important that you understand the properties that are on the book, on the grade 12 textbook. Very important, grade 11, I mean, textbook. It's very important that you go back there and you can find the properties of a slightly equilateral, right? You can read them there and also go through the theorems from number 1 to number 9. You'll be able to solve this question. So how now do we tackle this question? So today I'm gonna give you a clue as to how you're gonna go about tackling it, right? So let's start. Let's start, guys. So 9.2. So remember they said P1 and P2 are equal to X, right? So our P2 is equal to X, and there is our P2 there equal to X, and it's given. Remember, it's given on the statement, and also the Q2 is equal to P2 because of what? Of a tan chord theorem, right? So it's our P2. There is our P2, and there is our Q2. Those blue dots, these blue dots, right? It's our Q2, right? Now, the reason being is that there is a tan chord theorem, or you can just say the angle between the tangent VQ is equal to a chord, which chord called RQ, right? So you can just say that and you're gonna have your marks. Either you say just tan chord theorem, of which is simple, or else you can just elaborate more. You can just say angle between the tangents VQ is equal to the is a chord or angle between the tangent VQ and a chord RQ. Then you're done. So since now we have our angle Q2, then we say Q2 is equal to V2. Why Q2 is equal to V2? Then there's a reason for that. It's because of the you can just say alternating angles, right? There is it. alternating angles, so they are forming as a shape. This is our alternating angles, and they are forming as a shape. So from there, we can also say now our v2 is equal to x, right? And that is proven above, right? And now they say therefore p2 is equal to v2, right? So now they're saying q2, where's our q2? q2 is equal to v2, yes, and q2 and v2, they are both equal to x, and the angles same segment, right? Or you can just say if this angle is same segment, or you can just say there's angles are suspended by the same chord, right? This is our p2, this is our p2, this is p2, and this is v2. They are suspended by the same chord, or which chord? Same chord of which is tq, right? So here's our, look at this, you can look at it just separately. You can just look at it separately. This PQT, right? Triangle PQT and triangle VTQ, right? So which is our chord? Here is our chord. So they are suspended by the same chord, of which is TQ, right? So from the properties of a cyclic quadrilateral, when the angles are suspended by the same chord, then that is one of properties of a cyclic equilateral. Then now we've proven that PT QV is a cyclic equilateral, right? So then you have your marks, right? Then you are done with question 9.2. Then let's move on to the last question. Last question says TQ is a tangent to the cyclic passing through or passing Q, W, and P. Where is Q, W, and P? Is Q, W, and P, right? So TQ is a tangent. Where's our TQ? Here is a T and Q. So it's a T and Q. So it's tangent to the cyclic passing through passing Q, W, and P. So here's our TQ. So now, so you have to prove that. So you prove that TQ is a tangent to the cyclic passing Q, W, and P. So the cycle, just a imaginary cycle. One will say, why is a cycle? It's a imaginary one. So how we solve that? So they say P, angle P is equal to Q3, right? So here's our angle P1 is equal to Q3. Where's our Q3? There is our Q3. Why? Because they are suspended by the same chord, or angles in a same segment. What is segment? Which segment? Segment V and T. Or they are suspended by the same chord, of which is V and T. That's how you can reason, right? Then you have a mark. And remember, P and angle P1 and angle P2 are equal to X, or they are equal to each other. And you can reason by saying that is given on your statement, right? Then therefore Q3 is equal to P2. So is our Q3, is Q3 is also equal to Q3, since our since P2 is equal to P1 and P1 and P2 are equal to X, and we also proved that Q3 is equal to X as well. Therefore, P1 is equal to P2, and Q3 is equal to P1 and is also equal to P2. Then that is proven above. Therefore, Q is a tangent to the side passing through QW and P. That's how we solve actually this question. That's how we solve the Euclidean geometry, especially here we were using the theorem from grade 12, from grade 11. So it's very important that you go back to your grade 11 textbook. You go through that, and this question is for grade 12 learners and grade 11 students, just grade 11 learners. So it's very important that you look at this question, you practice it, and if you don't understand, it's fine. You are free to ask me on your comment section. And I also have a Facebook page, which you can also involve me there if you have any question on this question Euclidean geometry. The reason why I've created this video is because of the student busy asking me if maybe I can make a video on Euclidean geometry. So I decided now to prepare it for you students so that you can be able at least to have a clue as to how to tackle the question on Euclidean geometry. I hope you find this video informative. See you next time. And again, don't forget to subscribe, like, and share to your friend. And I have my Facebook page. As I said, my Facebook the name of my Facebook page is Grade 12. Is Grade 12 in mathematics for Grade 12 learners. Just say that is for Grade 12 learners. That's where you'll find me on the inbox, so that we can also talk more on the other chapters. Maybe you have some we are struggling because now we are about to finish, we are about to end the year, so it's very important that you have your time on that, you have your understanding where you live. And you don't understand the guide student, feel free to ask. I'm there for you. Right. Thank you for your time. Bye.